Part 4? No, part 3. Looking again at this general information, chapter 1. If it's useful, yay. If it's not useful, don't worry. The textbook tells you what you really need to know. Let's say something now about pathological anatomy. In pathological anatomy, what you're doing is you're looking for changes in body structures that would indicate that something isn't normal. An easy example of pathological anatomy would be something such as a person has, an arrow sticking in them. They have an open wound. They have a strange bulge. They have a sore. Or if you're looking inside the body, say with an X-ray or something, you can see a broken bone inside the body, or some kind of abnormality in what you consider to be the general structure, the expected structure of the anatomy. So again, very useful. And when you're looking at your child early in the morning, try to determine whether they look well enough to go to school. You look at things such as whether their eyes or eyelids are sluggish or something like that, their pupils are even, if they have a rash, if they look flushed, stuff along that line. So pathological anatomy. Radiographic anatomy. In radiographic anatomy, you're now using non-invasive imaging techniques such as X-rays, DSRs, MRIs, PETs, DSAs, and CTs, or CAT scans, in order to look inside the body and see something that's abnormal. Again, it's a non-invasive technique. This is not surgery. This is just taking a picture and looking at abnormalities based upon that. Well, let's slide on over here and start talking a little bit more about physiology. Physiology refers to the functions of the body. This is the physics and chemistry of what's going on. And here are some examples of types of physiology that you're probably familiar with, just not necessarily with the terminology we're going to be using. For example, cardiovascular physiology obviously has something to do with the heart, the blood vessels, blood pressure, heart rate, things along that line. So if you know that running up the stairs makes your heart beat a little bit faster, well, you understand cardiovascular physiology. An example of cardiovascular physiology that's kind of cute is called oxygen debt. With oxygen debt, if you overexert yourself, you use up the stored oxygen inside your skeletal muscles. It was stored on something called myoglobin. We'll talk more about this when we get around to chapter 10. But if you use up the stored oxygen inside your skeletal muscles have to pull the oxygen out of your circulating blood, off the hemoglobin. Well, if you do that, now you have a deficiency of oxygen in your hemoglobin, and you have to pull oxygen out of the air to refill that. Well, when you begin to exert yourself dramatically, like running up some stairs and such, there is a kind of a lag between your ability to breathe fast enough to replace the oxygen that was needed to replace the oxygen in your bloodstream that was needed to replace the oxygen that was stored inside your skeletal muscles. That little lag right there is called oxygen debt. And this is the reason why after somebody does something, like run up a flight of stairs, they find themselves breathless for a moment. They find it difficult to catch their breath. It takes them a while before they can start breathing normally again. That breathlessness is called oxygen debt. Neurophysiology refers to your nervous system. And you're very familiar with this because it's all about neurotransmitters, environmental influences, all kinds of topics involved right here. For example, you drink a strong cup of coffee and you feel a little buzz. That's neurophysiology. Drink too much coffee and try to go to bed. You can't really do that very easily. Neurophysiology. Any kind of altering drug, such as alcohol or something that's illegal, those kind of things affect your nervous system, your awareness, comprehension and such. Those are examples of neurophysiology. And of course, in your environment right here, we're talking about things such as carbon dioxide. If there's high levels of carbon dioxide inside the environment where you are, say you're wearing a mask, it builds up inside your bloodstream. It changes the pH of your blood, and that change of the pH of your blood will change your nervous system's ability to work. So some people suffer from respiratory acidosis by wearing a mask, and this slows their nervous system down. So an example of neurophysiology based upon respiratory physiology. And so respiratory acidosis is when you accumulate a lot of carbon dioxide inside your bloodstream, and it changes the pH of the blood, If it goes down, if the pH goes down, that tends to suppress your nervous system. If you blow off the carbon dioxide by hyperventilating, you can cause a condition called respiratory alkalosis, in which your nervous system may spike for a moment, but then it'll crash later on. Anywho. So again, examples of respiratory physiology. Reproductive physiology, well, this is complicated stuff, but in this graph right here, we're seeing real simply what happens to hormone levels throughout life. For the female, very low levels of sex hormones until low puberty, and then there is a wave and a flush and a wave and a flush and a wave and a flush all through the cycles from first cycle to last. And then there is a resumption of the original level, which is relatively low estrogens and relatively low levels of testosterone. That's her story. Kind of complicated between menses and menopause right there. His story is kind of simple. He makes it to puberty around age 14, and whoa, the testosterone production goes way up and begins to settle down as he gets older. So when it comes to reproductive physiology, hormones, her story is kind of complicated. His is relatively simple. Also when it comes to reproductive physiology, and we're talking about the menstrual period right here, not the menstrual cycle right here. Let's say you have a so-called normal 28-day cycle right here. Day 1 through 5 is the menstrual period, the show of to the outside of the body of the broken down endometrium. Then somewhere around day 14, there's ovulation. And between day 14 and 15, the egg is viable as a target. So there's that short window of opportunity right there for the egg to be present, to be able to be fertilized, and for the fertilization to be successful. Then between day 15 and day 25, if the egg was fertilized, there's about 10 days there for, as we said before, that fertilized egg, the zygote, to get down to the uterus and implant itself, produce HCG, and remind her that she is pregnant. If the HCG isn't produced in time and sort of delivered to the brain, her endometrium will begin to break down between day 25 and 28. If there was anything attached to it, whatever's attached to it will be lost. So again, there's an example of the menstrual cycle with the menstrual period within that. So hormone levels, and again, social impact. Social impact would be this. Here's the only a moment of time in which she might become pregnant. It's between days 13, 14, 15, because sperm tend to be viable for approximately 48 hours within her system, possibly. Delivered on the 13th, bumps into the egg around the 14th to the 15th, that's the possibility. So out of 28 days in this so-called normal cycle, there's really only 2 days that fertilization is theoretically possible. Let's go down here to pathophysiology. In pathophysiology, we're talking about the changes of the chemistry, the mechanisms of the body, and cancer is a good example of that. A normal cell begins to malfunction. As the cell malfunctions, the tissue malfunctions. And another example of pathophysiology is if an endocrine gland, for some reason, begins to overproduce or underproduce. It messes up the chemistry of the rest of the body because of those odd levels of enzymes that are produced. Hormones that are produced.